In this video we're going to have a look at expanding binomial products. So for example, we've got the expression x plus 2, x plus 3 being multiplied together. I'm going to be able to work this out, but before we do that I'm just going to go back to some geometry. Let's say we've got a rectangle. So I'll just draw a rectangle here. And we've got a length and a width. If I was to work out the area of this rectangle, I would be multiplying the length by the width. So because we don't know what they are, let's give them some values. Let's say the length was 56 and the width was 43. I could work out the length at the area by saying 56 times 43. And then I'd probably put my calculator, get my calculator out and type that in to get a whole number. However, let's say we don't have our calculators and we're going to work out this by an algebraic approach. Instead of 56, I could actually say, let's simplify it. Let's say it's 50 plus 6. I'm going to multiply that by, instead of 43, 40 plus 3. So I'm just splitting it up into smaller components. So on my diagram, how does this look in terms of our area? The length is 50 plus 6. So I'll use a different color here. Let's say it starts here at 0, goes all the way across to 50, roughly there. Alright, so that's 50 units. And then from here to here, let's say that was 6 units. Alright, and then for my width is 43, so 40 plus 3. So from the bottom to the top, well, that's 40 units. Actually, I'll put on the outside 40 units, and then from the top to that part there, that's another 3. All right, so what have we created? Well, we know this is 50 units. And we know this is 40 units. Alright, so essentially, instead of one whole area, we're splitting it up into 4 smaller parts. This large rectangle here could be worked out by saying it's 50 units along the top and 40 units along the side. 50 times 40. Alright, I could work that out. 5 and 4 gives me 20. And 2 zeros I add at the end, so 2000. Now this area in here, let's get rid of that 50 there, because that's on the outside. This area here is going to be 50 units long by 3. So 50 times 3. 50 times 3 is 150. And then we've got this rectangle here, that's 40 units long, 6 units wide. So 40 times 6, 40 times 6, well, 4 and 6 is 24. So that would be 240 by just adding the 0 at the end. And then finally 6 and 3, 6 times 3 gives us 18 units. So my whole area would be the addition of all of these smaller rectangles. So we've got, first off, 50 times 40, and then we've got a 50 times 3. We've got a 40 times 6, and a 6 times 3. In fact, actually what I'm going to do is I'm going to say, instead of 40 times 6, I'm going to say 60 times 40 and 6 times 3 there. Right, and to get my total area, I'm just going to add all of those together. In total, 50 times 40 we worked out as 2000. 50 times 3 was 150. 6 times 40 was 240, and we've got 18 at the end here. So now we've got an easier equation to work with. So if I was to add all of these together, I would get a 2, actually I would go 8s, so add the units up, we've got 8. The 10s, we've got 4, 1 makes 5, plus 5 is 100, so we've got 0 plus an extra 1 for the hundreds. 2 and 1 make 3, plus 1 is 4, so we've got 2,308 units. Alright, so what we've actually done in here is an algebraic approach, because essentially what we've done is we've expanded a binomial product. Let's just go back here. 50 times 40. If I was to draw an arrow for each of these, what does it look like? I'm multiplying 50 by 40. I'm multiplying 50 by 3. Okay, there's those two products there. And then I'm looking at the 6 times 40 and the 6 times 3. Alright, so similar to our distributive law, we've kind of applied the same approach to this binomial product. Essentially what we're saying is every element inside the first set of brackets is going to get multiplied by every element in the second. So I'm multiplying the 50 by each of the 40 and the 3, and the 6 is multiplied by the 40 and the 3. Alright, so that is one way that we can work it out. So let's apply that to our unknown question. We've got x plus 2, x plus 3. So what I'm saying is every element inside the first bracket is going to get multiplied by every element in the second. So x is going to get multiplied by the x. It's also going to get multiplied by the 3. So let's start off with that. X times x gives us x squared. X times 3 gives us 3x. Right, now let's move to the second one. We've got 2 getting multiplied by the x, 2 multiplied by the 3. So plus 2 times x gives us 2x, 2 times 3 gives us 6. And then we say, alright, well, what are our like terms? We've got an x squared term, a 3x and a 2x makes a 5x, and then 6 being added at the end there. So that's expanding the binomial products. And this is kind of the numerical way of what we're actually doing, and hopefully that makes a bit of sense. So let's just do another example to finish off. So let's say we've got x plus 8 and x plus 4. And so to recap, we draw a line from each element in the first to every element in the second set of brackets. So x and x, x and 4, 8 and x, 8 and 4. So x and x gives us x squared, x and 4 gives us 4x, 8 and x gives us 8x, and 8 and 4 gives us 32. And then finally collect your like terms. So x squared plus 4x and 8x gives us 12x plus 32. Alright, so that's pretty much the method for expanding binomial products.